So that'll put us in good shape. So then on Tuesday, I'm going to start some new stuff that's not on the test, and you don't have to do the homework on it till after the test. And then I'll review as well. So Tuesday will be a half covering 6-4, which is not on the exam, and the other half, or maybe even more than half of the day, will be a review. I'll review practice exam number 4. So you might want to look at that this weekend. That would be a good plan. That's the way people who do well on the tests do it, is they spend time in advance looking at those practice exams. So you want to take a look at that, and I'll be going over that on Tuesday in class, and then we'll take the actual exam on Thursday. It's our last exam other than the final, which is right after it on the 16th, or 2 weeks after it, on May 16th. It's on your syllabus if you want to know where the final is. On your original syllabus I gave you on day 1. May 16th at 11 o'clock, Tuesday, is our final. All right. Point on the terminal side is given. And we're supposed to find the values of the trig functions. Good morning to you. I don't know if I said that officially. Hope you're doing well. Don't you love these spring days? I love the weather in Fresno in April and May. If it could always be April and May in Fresno. All right. So let's find this. So we learned the definitions. Sine, for example. What's the definition of sine? It's not just y, is it? It's y over r, we talked about last time, right? And cosine is x over r, etc. So let's go to the unit circle. And let's put some angle theta. And this is the point over a fourth, down a third. The reason I put it down there in the fourth quadrant is because I was looking at the coordinates. It's over, positive to the right 1/4, and down negative 1/3. So it's over and down, right and down. So it's fourth quadrant. Okay, so that's some angle theta, like that, or like that. So now that means this is over 1/4 and down 1/3, huh? So I can find the r, the radius, by what? Pythagorean theorem, huh? So find the radius by the Pythagorean theorem. So a squared plus b squared is c squared. So 1/4 squared plus minus 1/3 squared equals r squared, right? We're good to there. I'm kind of running out of room. Bring it up here. That'd be 1/16 plus 1/9 is r squared. It's a little messy, huh? These fractions to deal with. So what are we going to do with that? 1/16 plus 1/9 is r squared. Common denominator. Multiply top and bottom by, you can use calculator or whatever it takes. I'm going to multiply top and bottom by 9 on the first one, top and bottom by 16 on the second one. That'll make the two denominators whatever 9 times 16 is, huh? 144. So that'll make it 9 over 144 plus 16 over 144. And that's very nice. It's 25 over 144. Root it. 5/12 r is 5/12. Excuse me. So we got r. Excuse me. So we got r. After all that fraction work. So we got r. So now we can go back and figure out what the sine is. The sine is y over r. So the y value is the minus 1/3 over the r, which is 5/12. r is always positive, by the way, because it's a radius distance, right? Distances are always positive, aren't they? When I say I'm going to go down south to LA, I don't say it's negative 400 or 250 miles because it's down. We just say 250. Distances are always given as positive, right? So radius is always positive. So flip that 12/5 up. So you got negative 1/3 times 12 over 5. Right, when I flip that up, 3 goes into 12 4 times, negative 4/5. So there's the sine, after all that work, negative 4/5. The sine of theta is negative 4/5. And so we got the sine. Now, we don't need, and then we could get all the rest from there, right? Cosine would be x over r, and we could do that. Is that okay if I just stop there and go dot, dot, dot for the others? Questions on that one? Is that making sense? What I'm doing there? You all good? Get that copy down? Am I rushing too fast? So I used the Pythagorean Theorem, a squared plus b squared is c squared, plugged in the fractions, a fourth and a third, then I brought it up here, kind of sloppy, sorry, had to kind of go down and then back up, and then I had to get common denominators with those fractions, and I square rooted it and found r is 5/12. So, why do I say sometimes that the sine of theta is y, and sometimes I say it's y over r? Am I confusing you with that? Do you see that? Why do I say that the sine of theta is just the y value? You hear me say that a lot. Sine is just the y value. Cosine is the x value. That's true in what situation? Which is normally our situation. Unit circle, right? If the radius is just 1, then that's just y, which is normally where we're at. We're normally on the unit circle, the radius 1. So unit means 1. So the unit circle means the radius 1 circle. So yeah, since 99% of the time we're just on the unit circle, then the radius is just 1, so you don't need to put the y over r. You just say, hey, sine is just y. And cosine, you don't need to put x over r. You say, look, if r is 1, which 99% of the time you're on the radius 1 circle, cosine is just x. Right? That making sense? But if for whatever reason they force you to be on a circle whose radius is not 1, like they are doing here, this circle that they made up giving me these numbers is got a radius that's not 1, it's 5/12. So then I've got to use the whole formula, y over r, technically for sine, and x over r for cosine. All right. You all have had trig before. You might be able to see the trick. It's pretty tricky. If you put these on a graph, the trick on this one, if you put these on a graph, I think you can see it rather than me just like doing some manipulative thing where I move things around. Let's just put it on a graph. So a sine of 40, where's that? Well, you know 45 is halfway about, 45 is right there, right, halfway between 0 and 90. So 40 is just, I don't know, a little shy of that. Maybe, let's just say there, for example. Just generally eyeballing it. Where's 125? Well, 90 straight up. 135 would be right in the middle because that's another 45 added to 90. So 125 is just a little bit back of that. 125 is about right there, maybe. I don't know, roughly. Where's 220? 220 is, here's 180. 220 is 40 more, isn't it? So that'd be halfway, that'd be 45. So it'd be about right here. 220 is a little short of halfway. Everybody seeing that? Think about this for a minute. And think about it. Before I go any further, I know I've got one more to put on the graph, but think about this dot and think about this dot for a second. Notice how this is 40 degrees up that way, and this is 40 degrees down that way, huh? They're symmetric, aren't they? They're the same distance up and down from the axes, right? From that axis line. 40 degrees. Okay, so what? Well, they're asking me sine. So they don't want everything about this point. They don't want his x, they only want his y. Because remember, sine values are y values, as I was just saying. On a unit circle, I made this circle up, so I'm saying it's a unit circle. It's a radius 1 circle. So anyway, when they say, what's the sine of 40 degrees? I have no idea what it is. I'd have to have a calculator to do it. It's not one of my memorized values. But whatever it is, I know it's the y height to that dot, isn't it? And whatever the sine of 220 is, it's the y height down to that dot. So what do you think the y height to this and the y height to that are? Well, they got to be the same. One's positive, one's negative. The same, whatever they are. You seeing that on the graph? Because they're both 40 degrees off the axis line, huh? So whatever height this dot has reached, this dot has reached the same depth because it's gone 40 degrees, just like that one's gone 40 degrees. So my point is, whatever this is, it cancels with that, doesn't it? This and this add up to equal 0. And the 125 is going to do the same thing with the 305. Because 305 is what? Here's 270. 305 would be, I don't know, what is it? 35. So here's 45 in the middle. 305 is 35 off of that. And this is 35, right? Yeah, off of that. See how this dot and this dot are both 35 off of their axis, off the y-axis? So the height, remember sine, they're only saying sine, 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 sine. No cosines or anything, tangents or anything else. It's all just the sine of these dots, which means the y height, right? Sines or cosine is x, sine is y. So the y height of that dot and the y height of that dot, again, they've got to be the same. One's positive, one's negative. They're going to cancel. So what's the answer to this whole thing? 0, right? Because these two make 0 and those two equal 0. So just by the picture, you can tell, by the symmetry of the picture, you can tell that these two y values cancel and these two y values cancel, don't they? Is that good? It's a little trickery there, just looking at the picture. Questions on that one? Are we good? Are we extremely happy about that problem? I don't think you look extremely happy. Mildly entertained? No? All right. So we'll try that. So the cotan of theta is 7, and they want me to find f of theta plus pi. Now, first off, f is just cotan. So when they say f, I don't know why they brought f in. It's just cotan, right? So they're giving me the cotan of theta is 7, and they're saying, what's the cotan of theta plus pi? Because f is cotan, they're saying right there. So what happens to a cotangent function if you add pi inside the x value? Well, the answer is going to be 7 again. The reason is because the period of the tangent and his upside down, his reciprocal, cotangent, is pi, or 180 degrees. Are you aware of that? They're basically seeing, if you know that cotangent and tangent, their period, their cycle of repetition is pi. Every pi, or say 180 degrees, same thing. They repeat values. So every 180 degrees, every half a circle, cotangent just keeps repeating his values. So does tangent. It's for the other functions, the other four, sine and his reciprocal, cosecant, and cosine and his reciprocal, secant. For those four, anybody know what their period is? It's 2 pi or 360. Yeah, so it's important to know those periods. You want to write those in your 3x5 card. You know, for the next exam, the periods of the various functions. They're going to test us on that more thoroughly here in a minute in the next section, 6.3. So let's just get them on the table right now. So the period of tangent and his reciprocal is 180 or pi. The period of the other four trig functions is 2 pi. Now, what does period mean? Time of cycle repetition. Meaning every 180 degrees, all the values of tangent, he cycles through all his values in 180 degrees and starts over again. So, for example, if I was to say, what's the tangent of 10? It's going to be the same thing as the tangent of 190. Do you see why? Because this is 0 plus 10. This is start of cycle, 10 down the road. This is start of cycle, 10 down the road. It's going to be the same thing. They're both 10 degrees past the start of cycle. You getting the idea? It's just going to repeat its values in the new cycle. Right? So anytime you're at 180 or any multiple of 180, 180, 360, 540, whatever else, it starts over again. So however far you are past the start of a new cycle, 10 degrees, making my own pencil there, 10 degrees past the start of a new cycle, right? If we're at 10 or we're at 190, both cases we're 10 degrees past the start of a new cycle. So it's going to be equal. Let's see if the pencil still works. Okay, good. I could do a commercial for it there, right? You can throw it around and it still works. All right. So cotan then is just going to be 7 because whatever theta is, I don't even know what theta is. But if your theta past the start of a new cycle, it's going to be the same value. Good? All right, so they're saying we got sine and we got cosine. And find the exact value of negative g of theta. Theta is 45. Okay. What's the cosine? So basically they're saying negative, and what is g? G's cosine. Negative cosine of 45. That's just a fancy way of saying find the negative cosine of 45, right? Because g is cosine, and they're plugging in 45. So they want negative g. They want negative cosine of 45. So let's go to the unit circle. Anybody know what's cosine of 45? I'm expecting great things, right? You guys have had trig before. And it was your favorite class ever, and you remember every detail of it, right? Cosine of 45? Root 2 over 2. Yeah. Let's go to 45. 45 is right in the middle here, right? 45 is exactly halfway between 0 and 90, right? So it's right smack in the middle. And in the middle, remember how we do... remember how we get values. Remember, I'm going to give you an exam 4. Remember that part 1 will be the trig, no calculator at all, right? Part 1 will be 6.2 and 6.3 only. Nothing else will be on part 1, which is the trig. And it'll be no calculator at all. No calculator at all. So you'll need to be your own calculator. Work out things by hand on that. Maybe some of you are like a human calculator. I'm just joking around. You guys know who the fastest human calculator in the world is? Have you seen him on Google? I think he's still the champ. It's been a long time now. I saw him a long time ago at a math conference, like maybe 12 years ago, 13 years ago, at a math conference in Monterey. There's like 400 math teachers all came to this big conference in Monterey. And they said we were going to see the Guinness Book World Record holder, fastest human calculator in the whole world. Number 1 in the world. Didn't even say whether it was a guy or a gal. It just said, and no picture, no description, nothing. And I think what was so funny to me personally is my own just stereotypes kind of came into my mind. It's funny. You don't think you totally have those, but you do. Anyway, I just assumed, we didn't know what. I assumed when that stage opened at the big hotel there in Monterey with the Guinness Book World Record holder, fastest human calculator in the world, I don't know what you would expect, but I expected some Asian or Indian, young boy or girl, skinny and small, maybe 15, 16, come out and go, hello, I'm the fastest human calculator in the world, it was in my mind, I guess, And the curtains open, and out popped this, what was he then? Probably 36-year-old white guy with a, medium build, totally could be your neighbor. I mean, American, just regular white guy. And I'm like, what, you? You're the fastest in the world? He's like, hey guys, he's Mr. Casual Sweats, and just Mr. kind of goofy. And I'm like, really? And he is. He's still, you type it now, he's like 50 something. Type into Google. He just ever said, he doesn't even have a college degree. He just, 4th grade, he just realized he could just do the numbers in his head. Crazy big numbers, crazy fast. He can, as fast as he can say them. He raced a TI calculator on the big screen there in the hotel. Fast as they can push the buttons, he can crank out the numbers in his head. And he'll like try to say, he said he can't say it wrong. He'll start to say something and his mind will correct him. He's just always had it from a young age. Anyway, it's just kind of funny. I was sure it would be an Asian or an Indian person from a faraway land, but no. Could be my neighbor out mowing his lawn. You know, it's just kind of weird to me. Anyway, so I understand you're not all the fastest human calculator, but the calculations will be pretty easy on our exam. So let's do this. So being able to do this one by hand, how do we do sine, cosine, and tangent by hand? Remember I gave you the small, medium, large to help you memorize. Remember the small, medium, and large? And to help you remember, it would be root 1, root 2, root 3, all over 2. Remember that from last time? So the easy way to memorize, and I think it is important that you memorize. Normally I'm not into memory. You've noticed that, right? You can still use a 3x5 card. I don't mean memorize. I mean don't use a calculator, right? I think it's important to be able to do these trig functions without a calculator because in calculus you do limits. You have to know the direction, not just individual values. You have to be able to feel the direction and see it on the circle. So put this on your 3x5 card. You know, you can have that during part 1, but no calculator. So small, medium, large, put it right in your 3x5 card. And then whenever you've got a spot, you just ask yourself, is it over and up, small, medium, or large? And remember, small always goes with large. Small never goes with medium, and large never goes with medium. Small and large go together, and medium goes with himself. This one's over, medium, up, medium, huh? Remember how it works? Whereas if you're up here, like it's 60, that one's over a little bit, up a lot. Over a small amount, up a large. Or if you're way over here at close at 30, you're over a large, up only a small, huh? Remember how to find all those values? So that's been a mess of things. Let's put it back the way it was. So we're right in the middle at 45. Right in the middle at 45. So we're over medium, up medium, right in the middle. Medium always goes with medium, and that's root 2 over. It's easy to remember, root 1, root 2, root 3. And the root of 1, by the way, you don't even need the root, huh? It's just 1. Root of 1 is just 1. I'm just doing that to show the pattern easy. Root 1, root 2, root 3, all over 2. So anyway, medium, root 2 over 2, root 2 over 2. That means this dot here is, whoops, not 3, huh? Is root 2 over 2. Over root 2 over 2, x root 2 over 2, y root 2 over 2, over and up. And remember, x values are always, what, sine or cosine? Cosine, right? Remember they're reversed. X values are always cosine, y values are always sine. It's reverse of the way you might think, right? That's how we find the values. So right here, what do we want? Cosine, x value root 2 over 2, but there's also a minus in front, so the final answer will be negative root 2 over 2. Good with that? Remember how to find those? Feel like you can do that. Put that information on your 3x5 card for the test on next Thursday. Questions? If I flash off of this one? So here we go. They want g of theta squared. Well, g is just cosine. I don't know why they keep putting in function letters. Anyway, they want cosine squared. And what's theta? 30. So we put in 30 there. So basically, long story short, they want cosine of 30 degrees squared, right? They want g squared, and g's cosine, and they're plugging in 30. So they want cosine of 30 squared. So I got to first find the cosine of 30. Go to the unit circle. Can you do that real quick? So go ahead and put a dot at 30 degrees, right? Here's 0, here's 90, so 30's, you know, close over here, right? And then draw your triangle over and up and see if it's over small, medium, or large. Is it up, small, medium, or large? And put the numbers down there. Find the coordinates of that dot. And remember, cosine is the x-coordinate. Sine is the y-coordinate. So it's clearly over a large amount, up a small amount, huh? It's way over, only a little up, huh? So it's over root 3 over 2. It's only up a little bit, so it's only up a half. So the coordinates are root 3 over 2, up a half. That's the x and the y for this dot. That's the coordinates. And the x is cosine, the y is sine. So what's the cosine of 30? Root 3 over 2 squared be 3/4. We good? I removed the root and squared the 2. 3/4. Cosine of 30 squared is 3/4. Is that good? Questions on that one? No questions? All is well? Okay. So they're wanting us to, they're saying f is the sine, g is the cosine, add at 60 degrees. So basically they want the sine of 60 plus the cosine. They're just adding up f and g, and that's sine and cosine, they say, and plug in 60 degrees. So basically they want the sine of 60 plus the cosine of 60. So can you go to the unit circle again and draw your 60-degree angle? $60 degrees is up there kind of close to 90, right? Past 45, past the halfway. So draw your triangle over, straight over, and from the origin, straight over and straight up to 60. Think about small, medium, and large. Root 1, 2, 3, small, medium, large, over 2. So it's over a small, up a large, isn't it? Over a little bit, up a lot, huh? Because it's past halfway. So it's over a half, up root 3 over 2, right? 1, 2, 3, small, medium, large. Root of 1, 2, 3 over 2. So then the coordinates of this point are over a half, up root 3 over 2. Cosine is the x. It's reversed, remember, of the way you, of the normal order. Cosine is always the x. Sine is always the y. So sine of 60, root 3 over 2. Cosine of 60, a half. That's it. You can't really do much. I mean, you can make it one fraction if you want. I don't care in a test. That's the same thing, whatever. Either answer is totally good with me. They're both the same, really. There's nothing more we can do. Is that good? Oh, man. That's what Math Excel wants to, because they want the exact answer on that one. Good. All right. Okay, so what is that funny little circle in the middle? What does that thing mean? A funny little circle in the middle between the F and the H. I bet you remember it's been a while. It's been a good couple of months. What does it mean? Yeah, it means F of H, exactly. It means it's composition. I'm not going to test you on the names, but it means one's plugged into the other like that, exactly. Remember that little circle? It's composition, it's composing. It's putting one into the other. Like in a musical composition, they put all the instruments into the piece of music, right? So you put one function into the other. It's a composing together of the two functions. So, and F is just sine, and H is 2x. That's weird. Okay, yeah. Look up here. F is sine, so I can make the outside just be sine. So far, so good. So the F is sine. The outside is sine. And the H, what is H? What is H? 2 times x. So what does that do? 2 times pi over 6. Does that make sense what I did with that H on the inside? The H meant take 2 times whatever you have. 2 times pi over 6. And then 2 times pi over 6, 2 over 1, 2 goes into 6 3 times. It's the sine of pi over 3. Is that good to there? So basically they want the sine of pi over 3. Bring it up here. Got a little more work to do. So what do you do with a pi? I don't naturally think in radians. I more comfortably think in degrees. So how could I change that pi over 3 to degrees? What do we do? What's that pi become? Yeah, is everybody comfortable with that? Pi is just 180. So you just stick a 180 in the place of pi. So this becomes sine of 180 degrees over 3. So really, it's the sine of 60 degrees. So when all is said and done, they're really asking us to find the sine of 60 degrees. So we know how to do that. Go to the unit circle. 60 degrees is up here, right around there. It's over small, up large, over a half, up root 3 over 2. That's over a half, up root 3 over 2. Sine is the what? Cosine is the x. Sine is the y. Grab the y value. Root 3 over 2. There we go. Questions? Is that good? Am I going too fast? You guys got that all copied down? All right. I'm going to leave that points. Okay. So first off, they're saying f is sine. Find f of pi over 4. So f of pi over 4 really means sine of pi over 4. I don't know why they keep bringing in all these function letters, but basically f is just sine. So f of pi over 4 is just sine of pi over 4. Can you convert that to a degrees? No calculator now. See if you can do it without a calculator, because that's what you'll need to do on the test, part 1, next Thursday. So convert that degree to degrees and then find the value on the unit circle. So you pi is 180, right? So we put in 180 for pi. Now, divide. You can do long division by hand if you want to, but I think it might be easier just to kind of think about it in your head, right? When you're dividing something by 4, you're cutting it in half twice, right? Because a fourth is half of a half, right? So just think, what's half of 180? 90, right? And then what's half of that again? What's half of 90? 45, right? So that's just sine of 45 degrees. Okay, so then go to the unit circle. Here's 45 degrees, right smack in the middle. That's halfway between 0 and 90. So the sine, we gotta go over and up like that. It's over medium, up medium. So, and medium is root 2 over 2, right? Because they're small, medium, large, root 1, 2, 3. So the medium is root 2 over 2. So this dot is that, and sine is the y value, so it's root 2 over 2. There we go. No calculator needed. Good. Questions on that? All right, I'll keep moving. Let me know. You guys are such a quiet group. Let me know. Nod yes or no, speed up, slow down, Mr. Aaron, that way I know. I got to answer the other questions. Not only that, I really haven't finished the answer to A. It's weird the way they ask it. Look at what they're saying. What is the point on the graph of F? Now, careful. It's not this point. Why not? Why isn't it that point right there? Because that's not the graph of F. That's the graph of the unit circle. So what's weird is now I've got to convert it to the graph of f. Well, how do you do that? I'm not going to draw it or anything, but got to think about it. The graph of f. Now, what is f? Well, sine. F is sine, right? So when they want a point on the graph of x, that means they want an x, y value on the graph of f, don't they? That's what a point on a graph means. An x, comma, y value on a graph, okay? So great. How do we do that? Well, what's the x? Well, the x is what you plug into the function, right? It's f of x, right? What did we plug into the function? Pi over 4. You tracking with me? Right? Am I losing you? Look up here. See, here's the function. And they said, what's f of pi over 4? There's my x right there. Right? X is what you plugged into the function, right? So whenever you have a function, you want to be really clear on that. Whenever you have a function, f of x equals y, what goes in is x, what comes out is y. Whatever you plug into a function is x, whatever comes out. So that's by common agreement. They could have made it different. The whole math science world agreed that when it comes to functions and graphs, what you plug in will be x, what comes out will be y on a graph. So what did I plug in? I plugged in pi over 4. That's x. And what comes out, that answer, root 2 over 2, that's y. So there's what they actually want on part A. X, comma, y, which you plugged in, comma, the answer you got out, with parentheses. Because they said, what's the point on F? We need to do part B also. Is that good so far? Now, can we do, squeeze it over here. Can we do part B? What is part B? See, they're saying, use the answer from A, which is here. Use the answer from A to, which was a point, an x, y point, to figure out what is the point on F inverse function, right? Negative 1 power is inverse. What's the point on the inverse function of F? How do you take a point on a regular function, this is on F, and change it to a point on an inverse function? You just switch x and y. Remember, inverse functions just switch x and y? That's all it does. That's what it means to invert. You invert x and y. Inputs and outputs, x and y. So it becomes root 2 over 2, comma pi. Just switch the order. That's all you got to do. Inverse functions are just inverting the x and the y. Finally, part C. What is the point of that? What point is on the graph of that? Wow. Okay, we better do that. Let me go over here then and try part C. Okay, so they're asking me for a point again. And a point on part C here, a point, remember, means x, y, where x is what you plug in and y is the answer you get out, right? Let's be clear on that as we're rolling for this part C here. All right, so here we go. F of x minus pi over 4 minus, that's what y equals. Okay, now what is F? F is, it says right up here, F is sine, right? So y equals F, which is sine of x minus pi over 4 minus 5. We good so far? I'm just writing out exactly what they wrote here. Y equals F of x minus pi over 4 minus 5. And that's sine. F is sine, they said in part A, or right before the problem began. F is sine. Okay, now, what are we plugging in? What is x? Well, right there, x is pi over 4. So I've already got half my point. I got the x. That's a 4 there. X is pi over 4. Right? That's my x. They're telling me right here. No mystery. X is pi over 4. So all I need now is the answer. Plug in right there pi over 4. Good? That's the sine of 0. What's the sine of 0? Unit circle. Where's 0 degrees? Well, it's right there, huh? That's 0 degrees, huh? So what's the, remember, it's all about the coordinates, right? The x, comma, y coordinates. That point right there, what's his over and up? Yeah, over 1, up 0, huh? Because he's right on the axis. Over 1, up not at all. Straight over 1, up not at all. Remember, x is cosine, y is sine on the unit circle always. So what's the sine? It's just 0, huh? Sine is just 0. Take away 5, y is negative 5. So my point is pi over 4, comma, negative 5. That's the x they gave me, and this is the answer I got. That was a lot of work. A, B, and C. Questions on that one? All making sense? So point on a graph is x, comma, answer. All right. I'm going to flash off of that. All right, so they're asking me for the tangent of 405 degrees. So that's 405. That's a big angle. What do you do when they give you a big old angle like that? Yeah, it's more than a whole circle, isn't it? 405 is more. You can subtract 360. What is that, 45? So it's the same thing as asking what's the tangent of 45, huh? Right? Because 405 is a full circle 360 and then 45 more. So in the end, after you start here, let me draw the unit circle. If you start here, do a full circle of 360, then go 45 more. It's the same thing, it's just going 45, is what we're saying. So it's a 45 degree angle. Really, is what it is. All right, so give it a try. Find out what tangent. What's the definition for tangent? Tangent is y over x or sine over cosine. Same thing either way. Totally right. Yeah, so tangent is sine over cosine, which is y over x, because sines are y values, cosines are x values. Huh? So for the 45 degree dot, 45 degree, that one's right in the middle, isn't it? Between 0 and 90. So it's over medium, up medium, which is root 2 over 2, root 2 over 2, huh? Remember, small, medium, large, root 1, 2, 3 over 2. So medium is in the middle. It's 2, root 2 over 2. So that's root 2 over 2 over root 2 over 2. Flip this guy up. Boom, boom, 1. We don't need a calculator. You can figure that out by hand, huh? Tangent of 45 has got to be 1, which is the same thing as the tangent of 405, because it ends up at 45 degrees after a full circle. Good? Getting the hang of doing these trig functions by hand? So notice we memorized just the basic 3 in every quadrant, 30, 45, 60. And the rest we use a calculator for. That's how it works. It is valuable to memorize the 3 for limits. All right. Good. Am I racing ahead? You got that copied down? That equals 1. Questions? We all good? All right, you all have had trig before. Does anybody just know that one off the top of their head? Cosine of 26 pi? What do you do with an angle so big? I mean, I could put in the 180 if I wanted, but really, you know what? That's 26 pi. 26 pi. Isn't that 13 pi? No, wait. Isn't that, I'm getting confused. 26 pi, isn't that 2 pi 13 times? Right? So in other words, if you go to the unit circle, 2 pi is all the way around, right? 2 pi is 360, Right? You guys good? 0 degrees here. This is pi or 180. And then this is back to 2 pi or 360. So basically they've done 2 pi, 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 13 times and stopped right where they started. Right? It's just 13 full revolutions. So where does the dot end up? Right here where it started. And what's the coordinates at that point? Over 1, up 0. Right? It's the same as the starting dot. They just ended up where they started after 13 complete full revolutions. Cosine is the x value. Sine is the y value. So what's cosine? 26 pi. 1. Good? 13 full revolutions. All right. Okay. 25 pi over 6. I don't know that one off the top of my head. I'd put in a 180 for pi. Let's do that. Tangent 25 times 180 over 6. So I just plugged in pi. Pi is 180. Now, let's simplify that. You got to be able to do that by hand. The easiest way would be to divide first, actually. Instead of multiplying that 25 times 180 on the top, that's going to be a really, really big number in the thousands. What would be easier is to divide 6. How many times does 6 go into 18? 3, then the 0 makes 30, right? Just divide first, multiply after, and then what is 25 times 30? Well, what's 25 times 3? What's 3/4? 75 cents, and throw the 0 on the back. We could have done that in our head, huh? See what I did? I just divided 6 into 18 3 times, kept the 0, 30. And then 3 times 25 is 75, put the 0 back on the back. So that's the tangent of 750 degrees. Good so far? Now, what should we do with a big old tangent like 750 degrees? Yeah, start subtracting 360s, huh? Quickest thing would be to subtract 720, 2 360s. But, so if you notice that, this is just tangent of 30. But if you don't notice, that's fine. Just do a 360 first off, and what are we going to get? 7 put a 6 put a 1, what's that, 9, 390 degrees. And that's still more than 360. So we got to subtract another, still more than a full rotation. So finally we get down to 30. So really, this is asking us for the tangent of 30 degrees. Make sense? It's 2 full rotations, 2 360s, and then 30 degrees more. Does that make sense? So basically they started here, did 1, 2 full rotations, and then went 30 degrees more. So there's where they end up. Stuff out of the way here. So at 30 degrees. So let's find the tangent of 30. How do we find the tangent of 30? Over and up. It's over a large amount, up a small amount. It's over root 3 over 2, up a half. So it's over root 3 over 2, up a half. Cosine is the x, sine is the y, right? Am I racing ahead too fast? So cosine is the x, sine is the y. What's the definition of tangent? What is tangent? Sine over cosine. Or y over x, you know, either way. So the sine's a half. Cosine's root 3 over 2. What do we do from there? Give it a flip. 2's cancel. 1 over root 3, but we can't leave our answer that way. What do we have to do? Yeah, multiply by root 3 over root 3. And we get root 3 over plane 3. Is that on the screen? Yeah. Root 3 over plane 3. There we go. Are we good with all that? So big old angle, put in the 180, found it 750. Subtracted out 2 360s, it's tangent 30. Drew my unit circle. Found the tangent of 30. Feel like you'll be able to do that next Thursday? All right. Okay, do you know the rule for the sine? Did your trig teacher tell you about the all students take calculus? You heard that? It's just an easy way to memorize the sines. Start in the upper, you know how the quadrants go, right? This is the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. Remember, they start in the upper right-hand corner. They just go like that. It's like the angles do. 1, 2, 3, 4. Fourth quadrant. Just follow that pattern. All students take calculus. Is the truth in your life, right? Well, you're not all students, but all the students in here are planning to take calculus, maybe. I don't know. Anyway, all students take calculus. And so, what is that saying? That's saying that all there's 6 trig functions, right? All are positive. All 6 trig functions are positive in the first quadrant. In the second quadrant, only sine, and of course his reciprocal, his upside down, which is cosecant, are positive. The other 4 trig functions are negative in the second quadrant. It's telling you which functions are positive where, and the other ones are negative. So down here, tangent in the third quadrant, and of course his upside down, cotan, are positive. The other 4 are negative in that third quadrant. And in the fourth quadrant, what's positive there? C. What does C stand for? Cosine. And his upside down, secant, are positive, and the other 4 are negative. So they're all positive in the first, but then in the other quadrants, there's only 2 trig functions that are positive. In each of the other quadrants, the other 4 being negative. All students take calculus. Just an easy way to remember the positive, negative stuff for the trig functions. Okay. So with that in mind, sine of theta is greater than 0, which means positive, right? Tangent is less than 0, which means negative. What quadrant are we in? You see it? It's quadrant number 2. Why? Well, again, it's all about who's positive. Sine is positive. Sine is positive in quadrant 2. And not everything's positive. It's not quadrant 1, right? Not everything's positive. Tangent's negative. So it's not quadrant 1, because somebody's negative, right? So which other quadrant has sine being positive? Quadrant 2. Sine's not positive down here, only tangent and cotan. Sine's not positive down here, only cosine and secant. Must be quadrant 2. Is that good? Does that make sense?
Yeah.
All is well there? All right. Let's keep. All right, try that one. Think about the all students take calculus. Don't shout it out. Give everybody a chance to figure it out. So where cosecant greater than 0, they're saying positive. Now cosecant, that's the upside down of what? Sine. Yeah, you want to put those on your 3x5 card if you don't have them memorized. Cosecant and sine are upside down of each other. So it's saying cosecant positive, same thing as saying sine positive. And cosine is also positive. So where is it that sine and cosine are both positive? That's what it's really saying. Yeah, only quadrant 1. Quadrant number 1, are they both positive, right? Because otherwise, if you're in quadrant 2, sine would be positive, but not cosine. If you're in quadrant 3, only tangent and his upside down would be positive, not sine or cosine. They'd both be negative. If you're in quadrant 4, the cosine would be positive, but the sine wouldn't. So the only place where they're both sine and cosine are positive is where everybody's positive. Quadrant number 1. Quadrant 1. Does that make sense on that? You heard that before? All students take calculus? Is that how you learn the signs? How about the trickiest question of all? Why do they use Roman numerals for the quadrant numbers? Why don't they go 1, 2, 3, 4? Why do they always use Roman numerals for the quadrant numbers? Honestly, I have no idea, and I'm just kind of playing around. But my guess would be because they don't want to confuse it with numbers on the axes, I guess. They don't want this to be confused with these, I guess. That would be my guess. But it brings to mind the Roman numeral system. My favorite Far Side cartoon, probably my favorite ever. Have you ever seen the one with the guy trying to subtract in the Roman numeral system? You ever thought, you remember Roman numerals, right? You remember how they, M's like 1,000, I don't know them very well. C, D, X, 1V or whatever. Subtract, M, D, D, C, X, 1, 1. I mean, imagine trying to subtract in the Roman numeral system. I mean, it's not a place value system, right? I mean, how do you carry? How do you borrow? Right? So it shows this picture of this Roman guy, right? And he's trying to subtract in the Roman numeral system, and he's very confused. And the caption reads, "Another reason Rome fell." Probably one of the biggest ones. Their subtraction system was no good. All right, therefore. So sine and cosine. So can you do that? Is that something comfortable for you? Let me let you go ahead and try that. See if you can get tangent. First off, I'm going to start with that one. So, yeah, you want the by hand work, the exact work. A lot of flicker in here. Tangent is sine over cosine, right? So far, so good. Sine over cosine. They knew what to do, right? Flip up that fraction on the bottom. Flip it up there. Times negative plane 26 over root 26. Get to there. So then the tangent, let me see, the roots would cancel. The 26, it's just, what's the answer? Just a negative 5, yeah. Tangent's negative 5. Good on that one? So that's tangent. They want the other ones as well. They want, maybe we better do a couple other ones. They want cosecant. So let's do that. Can you, well, here, let's do cotangent first. That'll be an easy one. What's the cotangent? So it's just going to be the flip of the tangent, right? Negative 1/5. That one's nice. Now let's do cosecant. See if you can get cosecant. What's cosecant the flip of? Sine. He's the flip of sine. Want to get that? Make sure you know that. So the flip of sine is 1 over sine. So basically you just turn the sign upside down. So it becomes 26 over 5 root 26. Is that good so far? Right, so cosecant's 1 over sine, so you just flip the sign. Now I can't leave it that way because of the root on the bottom, huh? So what do? You know, you multiply top and bottom by the root of 26, right? Whenever you have a root on the bottom, just multiply top and bottom by that root, and you'll get 26 root 26 over 5. And what is on the bottom? What's root 26 root 26? Plane 26, huh? That's what two roots do, right? And then the 26's cancel, the plane 26's cancel, and it's root 26 over 5. So there's the cosecant, and then you could get the secant. That's the upside down of cosine, same way. Questions on that one? So once you got, notice that the other four functions all come from sine and cosine, huh? Right? So really, trigonometry is all about sine and cosine. All the rest are just Johnny-come-latelys after sine and cosine. They're just made out of sine and cosine, aren't they? Tangent is just sine over cosine. Cotangent's the flip of that. Secant is 1 over cosine, and cosecant's 1 over sine. They just different versions of the originals. So sine and cosine is trigonometry, fundamentally. And everything else comes from that. So no sine and cosine, well, you've got trig. All right, formula. All right, so they're telling me the cosine is negative 12/13. And they want me to find the sine. In fact, all of them. They're going to ask me for all the other trig functions. Let's start with sine. So how do you take cosine and then find sine? Anybody know? Do you remember? Did you do some of this in trig?
Gotta make it a triangle, right?
You could do the triangle thing. I'm going to save that, but you could do that here. If you're good at that, feel free to do that. I'm going to save that to when next week when we're doing 7-1, because we'll really have to then. But that'll work here, though. You could do that. I'm going to do something a little different. Do you remember the formula? There's a special, because that's a good way. And that's, to go ahead and do the triangle thing if you're comfortable with that. Remember the formula sine squared plus cosine squared equals 1? Do you remember that formula? That's what I'm going to use here. Well, first off, where does that come from? Why does the sine squared plus the cosine squared equals 1? Well, it's all from the unit circle. Let me just give you the reason. I don't like formulas without reasons. Take any point on the unit circle. Call that angle theta. You know, I'm at some angle theta here. Okay? So remember, if you're at a point, how on the unit, this is the unit circle, which means what? Radius 1. Right? Unit circle. The 1 circle, the radius 1 circle, this line, which is a radial line, a radius line, is 1. Then how far over, how far up? How far over is this? Well, the x is always the cosine. The y is always the sine. So this is a right triangle because it's straight over, straight up. That's what x and y coordinates always are at a right angle to each other, right? So Pythagorean theorem, x squared plus y squared is 1, meaning cosine squared plus sine squared is 1. It's just the Pythagorean theorem on the unit circle. That's where this comes from. Pythagorean theorem on the unit circle, right? Because cosine is x, sine is y on the unit circle. So therefore, sine squared plus cosine squared is 1. Okay, so what? Well, now plug in the cosine. So sine squared plus negative 12/13 squared is 1. So now we can solve for sine from that little formula. So sine squared plus, square that, you get 144 over 169. Could you do that by hand? Just, go off the side. If you don't remember those, go off to the side of your paper, multiply 12 by 12 and 13 by 13, Okay, now I'm trying to solve for sine. So how am I going to solve that for sine? What do I do next? Got to get sine alone. What do I do? Yeah, subtract 144. That's gone. Bring it up here. Sine squared theta is 1 minus 144 over 169. Now that's a little messy. How do I subtract such ugly numbers? How do you take 1 minus that big old fraction? What do we do with that 1? Yeah, make it 169 over 169. It's a big fancy 1, huh? Then we can subtract. We get some number, was it 25 over 169? We're almost there. Last step, right, root it. So root it. And when you put a roof on the house, you're supposed to go up and down the ladder, plus or minus, huh? Now, really, it's going to be only one. This is 5/13, square root of those. Do you know that one? You kind of have to. So it's 130, 169. You might want to test that in the side of your paper, or write that on your 3x5 card. Plus or minus 5/13. Now, which is it? Plus or minus? How are we going to know? Is the sign plus 5/13 or minus 5/13? Minus? How do you know? Yeah, look over here at the quadrant. That's why they told us where it's at. Otherwise, we wouldn't know plus or minus. They're telling us what quadrant. So go to quadrant 3, right? 1, 2, 3. All students take calculus. In quadrant 3, only tangent and his upside down are positive. All the rest are negative. So sine must be negative 5/13. Is that good? And now we have cosine, we have sine. We can get the other 4 because they all just come from sine and cosine, right? Tangent is just sine over cosine. Cotan, you flip, and on you go, right? Is that okay? You want me to do one of those? Questions on getting sine? Does that make sense, how we did that? So I just use sine squared plus cosine squared is 1. But you could do the triangle thing. All right, they're giving us cosine. They're telling us where the angle lies. They're asking us for sine. So give it a try. Try to use that same formula. Sine squared plus cosine squared is 1. Cosine is minus 3/10. Square the 3, square the 10. Good to there. Subtract the 900, so sine squared is 1 minus 9 over 100. Make that 1 100 over 100. Minus 9 over 100. What's that? 91 over 100. And then put the roof on the house, up and down the ladder. So sine is plus or minus root 91 over 10. Is everybody okay with what I did with the root there? Whenever you have a root that's on an entire fraction like that, you try to root the top and you try to root the bottom. You put it on both the top and you put it on the bottom at first. On the top, it just stays there because it can't root the 91. The bottom just becomes a plain 10. So the root vanishes on the bottom where it did its rooting job, right? All right. So anyway, now is it plus or is it minus? How do we figure that out? Why is it minus? How do we know? Where is it?
It says the pi is less than theta is greater than 2.
Yeah. Pi is, 180. And then 3 pi over 2, that's 3 times 180 over 2, right? Remember, you put in for pi, 180. The easiest thing is to divide this first. What's half of 180? 90, right? So it's 3 times 90, that's 270, isn't it? So it's telling me the angle is between 180 and 270. Where's that? Well, here's 0, 90, 180, 270. It's here. It's in quadrant 3. There's 1, 2, 3. It's between 180 and 270. All students take calculus. Take tangent. Only tangent is positive, so sine is negative. Only tangent and his upside down cotan are positive in quadrant 3. So sine must be negative here in quadrant 3. Is that good? Sine must be negative. So we got sine, we got cosine. We could find the other 4 trig functions by combinations of sine and cosine. Questions on that one? All right. Ones, I think, of this section. All right, so they're giving me secant. Oh, and then they're asking me for everything else in the world. So give it a try. Let me let you work on that. They're starting you with secant. That's different. The last 2 they gave me either sine or cosine. Give it a try. Let me know if I can help in any way. What do we do with the secant fact? Yeah, because secant is upside down a cosine, huh? So what is the cosine equal to? A half, yeah, 1 over 2, right? Secant is upside, so you gotta know that which ones are upside downs and which ones. So secant is upside down a cosine. So cosine, they're giving you cosine. So now do the same formula, right? Sine squared plus cosine squared is 1. We use that formula a lot. Trig. So sine squared is 3/4, huh? We good with that? Sine's √3/2, but is it positive or is it negative? What is it? How do we know? Yeah, look what it's saying here. Cosecant, they're saying cosecant is negative, right? Because it's less than 0. And cosecant is just the upside down of sine. So that means sine is also negative, right? Because cosecant and sine are always the same sign. They're just upside down, but they don't change their sign, right? So if cosecant is negative, so is sine. So sine must be negative. I don't even need to find which quadrant. I can just simply look and say cosecant is negative, so sine is negative. They're going to always be the same sign as each other. They're just upside down at each other, right? Reciprocal functions. So sine is negative, √3/2. So we've got sine and cosine. We can find all the other 4 functions now quite easily. Good? No questions on that? Because they're going to change the game here. All right, try that one. They're giving me tangent. See why I need to help you. There's a special formula. Anybody remember it? Tangent squared plus 1 equals the secant squared. Have you seen that one before? That's the other one I would put on my 3x5 card to use. 1 plus the tangent squared, or tangent squared plus 1, either way, is the secant squared. Now, where does that come from? Here's where it's from. You don't have to write down this from stuff. I just don't feel good putting something on the board like it's magic, though. So I want to show you where it comes from. If you basically just take the original one we've been working with, sine squared plus cosine squared is 1. Remember what you do? What can I do to this one to get that one? So we know where this one comes from. It comes from the unit circle. What can I do to that one, and that'll give me the new one? What do I do? Divide it. Yeah, what am I going to divide through by? What can I divide all 3 of those? What can you divide sine squared by to make tangent squared? Cosine squared, right? Because sine squared over cosine squared would be tangent squared. If you divide all the way through by cosine squared, you see there it is. Right? Because this is 1, this is tangent squared, and this is 1 over cosine is secant squared. So it's just the main one, divide through by cosine squared. Okay, so anyway, you don't have to know that, but it would be good to put this thing on your 3x5 card. Okay, so here we go. Plug in the tangent. Minus 3/8 squared plus 1 is secant squared. So that's what? 9/64 plus 1 is the secant squared. Okay. So now bring that up here. 9/64 plus 1 is the secant squared. So now for that 1, you know what I'm going to do with that 1? Make it 64 over 64 again. Which is what? 73 over 64 secant squared. And then root it up and down the ladder, plus or minus root 73 over 8 is the secant, right? Because you can't root the 73 on the top, so the root stays up there, but you root the 64 on the bottom, making it 8, and the root vanishes from the bottom. So root plus or minus root 73 over 8. Which one is it, plus or minus? Look here. That's saying secant is greater than 0, meaning secant is plus. So it's plus. Secant is positive. Okay, great. I've got secant. But they're really asking me for sine and all the other trig functions. So I've got secant, but how am I going to get sine? Good. Flip it to get cosine, right? Because remember, cosine's upside down with secant. So there's cosine. And I know we're not supposed to leave a root on the bottom. You know, you'd have to, technically you would want to multiply by root 73 over root 73. You'd get 8 root 73 over plane 73. And that's what cosine is. That's true. So there's cosine. I've got cosine. So I've got cosine, secant, had tangent from the beginning. But how do I get sine? I want sine. What could I do with this cosine now to give me sine? I'm going to go use the other formula, The sine squared plus cosine. This is a long problem here. So I'm going to go back then and go, okay, now sine squared plus cosine squared is 1, right? I'm looking for sine. What's cosine? Now you could use 8 root 73 over 73, but it'd be easier to use this right here. The cosine, before you simplified it, is actually a little easier to work with. They're both right. But I'm just going to use this one. Whoops. 8 over the root of 73 squared. So then sine squared plus what's that? 64 73rds is 1. Are we okay? Am I racing ahead of you? Is this making sense what I'm doing? So I did all that work with 1 plus tangent squared, and I found secant, flipped it and found cosine. And now that I have cosine, I can plug into sine squared plus cosine squared equals 1 to find sine. A lot of work. So subtract 64 73rds from both sides. So sine squared is 1 minus 64 73rds. I have to come up here. Not losing you. Sine squared is 1, which is 73 73rds minus 64 73rds. Sine squared is what? 679, 9 73rds. Root it, up and down the ladder. So sine is plus or minus 3 over the root of 73. Is sine positive or is sine negative? Depends on what quadrant I'm in, What quadrant am I in? Can you tell? All students take calculus. Secant is positive, which means cosine is positive. Yeah, fourth quadrant, Because tangent's negative. Not everybody's positive. And cosine is positive, so I'm in the fourth. So I'm in the fourth quadrant, which means cosine is positive, which means sine is negative, isn't it? So this sine must be negative. Oh, and you can't leave a root in the bottom. Multiply top and bottom by root 73. So sine is minus 3 root 73 over plane 73. That was a lot of work. So we got sine, and there's a couple other you could get easy now. So that was a lot of work. There's other ways. You could have used the tangent fact, right? Tangent is sine over cosine. And we had cosine. So we have tangent and cosine. You could have plugged those in and solved for sine instead of using this formula if you wanted. Oops, it's off the screen now. Instead of using this formula. You could have just plugged it. You know, the second part of the problem. So the first part of the problem, we had to use the 1 plus tangent squared is secant squared, for sure. Had to do that. Got our hands on secant, flipped it, and got cosine. But as soon as we had cosine, you could have plugged into the tangent, right? Do you understand what I mean by that? That would have been another way. Because tangent is sine over cosine, and tangent is minus 3/8. Plug in the cosine, which they gave me, which is 8 over root 73. Put sine on the top. You could have solved that for sine. That would have been another way. Or you could do this. I just did this because we're used to doing that to find sine. All right. Questions? A lot of work. That's probably the hardest problem we've done. Okay, so cosecant of negative 60. Yeah, do you guys know about the even odd thing from your trig days? Basically, the even functions are cosine and his upside down secant, and the odd functions are the other four. Sine and his upside down cosecant, and tangent and his upside down cotangent. So what? What's even and odd? Well, even means if you plug a negative angle in, like, let me just do it with cosine. If you take the cosine of some negative angle, the negative just totally vanishes, and you can just do the positive and you have the same answer. Odd, so negative, let me just write this out for back for even again. Negative plugged in vanishes. Odd, like if you take the sine of if you plug a negative angle in, that negative will come to the front. It won't vanish, it'll come to the front. So negative plugged in comes to the front. So that's the difference between an even and odd function. You remember where they got the name even and odd? Even is like x squared. Odd is like x cubed, odd powers, right? You know what happens if you plug a negative into x squared. Where's that negative go? It vanishes. It ends up being positive, right? Because negative to an even power vanishes. What about if you plug a negative into an odd power? Well, the negative just comes to the front in the answer, because odd negatives is negative, huh? So that's the idea with even and odd and negative plug-ins. Okay, so with all of that said, so that'd be a good thing to write in your 3x5 card or memorize. Even is cosine and his upside down. Odd is the other four. And even means negatives vanish. Odd means negatives come to the front. Okay, so cosecant is odd. So where's that negative going? Is he going to vanish or come to the front? Come to the front, right? They're plugging a negative in. And so that negative is going to come to the front. So you just move that negative. So basically you never have to do trig functions of negative angles. With these properties, even in oddness, you never have to worry about negative angles if you don't want to. If they plug in a negative angle, you can always get rid of it. If it's cosine or secant, it just fully vanishes. If it's any of the other four functions, the negative comes to the front. Either way, it's not plugged in anymore, right? So, okay. So what's the, so now to finish this problem is we've got to find what the cosecant of 60 is. Can we do that? What is cosecant? Cosecant is the upside down of sine, right? So this is really negative 1 over the sine of 60, huh? So we got to find the sine of 60. Unit circle. 60 degrees is up here. It's over a little bit, over a half, up a lot, up over small, up large. So the y is the sine, root 3 over 2. So it's negative 1 over root 3 over 2. Flip it up. Negative 2 over root 3. Can't leave a root in the bottom. Multiply top and bottom by root. Negative 2 root 3 over plane 3. Good on that? We found the cosecant of a negative angle. So again, with even and odd qualities, you never have to worry about a negative plugged in. You can always get rid of it. Either it vanishes for cosine or it comes to the front for the other four trig functions. Okay. So cosine, whoops, I messed that up. Come on. Here we go. So cosine of negative 90. Cosine's even. So where's the negative go? To the front or vanish? Vanish. Poof. It's gone. So it's just the cosine of positive 90. So positive 90, unit circle right there. What's the coordinates? Over 0, up 1. Cosine's the x. Sine's the y. What's cosine? 0. So I'm kind of whipping along now. Looking at that clock trying to finish. Is that okay? 90 degrees, straight up, over 0, up 1, cosine's the x. The negative vanishes. Of course, even if it hadn't, it wouldn't matter. It would just be negative 0, which is still 0. Turns out. All right, what's the sine of 23 times the cosecant of 23? Answer is 1. Good. Do you all know that? Because cosecant, remember, is 1 over sine. Cancel. 1. I don't have any idea what the sine of 23 is, but I know cosecant's the opposite, the upside down, so they cancel into 1. So just making sure you know the properties there. All right. Cosine of 395 times secant of 35. Any guesses? What do you do with that 395? That's a big angle. That's more than 360, huh? So what do we do whenever they give us an angle more than 360? Yeah, subtract 360, right? So it becomes cosine of 35. It's the same thing as cosine of 35, right? It's a full circle and 35 more. Times secant of 35, answer is 1, because secant's upside down again of cosine. Good. Easy enough. Can I flash off of that? All right, so sine of negative 59 over cosine of 419 plus tangent of 239. Okay. First thing to do, what do we do with that negative plugged into a sine function? Is it going to vanish or come to the front? To the front, because it's not cosine or his reciprocal. So you want to memorize cosine and his reciprocal, negatives vanish, the other ones it comes to the front. Or put it on your 3x5 card. Okay. Now what am I going to do with that cosine of 419? Subtract 360, and you get 59. That's convenient. Now, this is 239. That's weird. 239. What are we going to do with that? We can't subtract 360. Well, we could, but anyway, I'm not going to go that way. Remember the periods? I wrote them up. Didn't I write them up today? What's the period of tan in his upside down cotan? Pi or 180. Yeah, I did, didn't I? And what's the period of the other 4? Sine in his upside down cosecant or cosine in his upside down secant. Their period is 2 pi or 360. Right? That's why I keep subtracting 360 from sines and cosines, because they repeat themselves every 360. But tangent and his upside down cotan, they repeat more frequently. They repeat every 180. So I can actually subtract 180, and this becomes tangent of, guess what? 59. That's the trick they're wanting you to see. So it would be good, it would be helpful to memorize that tangent has the special period, only 180. The other 4, 360. The other 4, 2 pi, 360. And cosine has the special even property. And his upside down. The other 4 are odd. Negatives come to the front for the other 4. Negatives vanish for cosine. Anyway, so what does this equal then? What's tangent of 59? It's sine 59 over or I could go the other way. I could say, look, this is minus, this is minus the tangent of 59 plus the tangent of 59, isn't it? Sine over cosine is tangent. It's got a minus. So the answer is 0. It's a fancy way to say 0. Hold on a second. Let me make sure I've covered these last 5. I think they're simple. I want to make sure we all got that one copied down. So 180, you can subtract 180 from tan and cotan. 360. So the same idea. Tangent is 4. They're saying right there, they're saying, hey, tangent is 4. Tangent is some angle theta. I don't even know what theta is, but they're telling me it's 4. What's going to happen when you add pi or add 2 pi? Remember, tangent recycles every pi. So it's just going to do the same thing. These are all going to be 4. Answer's 12. We're done. Right? Because they said tangent is 4. So if you add pi you're at the same place in the cycle. You add another pi, 2 pi's, you've cycled back to the same spot again. You're at wherever theta started. Add pi or add 2 pi, you're right back where you started. 4, 4, 4, 12. On that. So tangent, when you see the words not defined, what do you think? How can a function be not defined? That's weird. Not defined? Divided by 0, exactly. Denominator 0. Remember what tangent is? Sine over cosine. So when the bottom equals 0, it'll not be defined. That's good thinking. That's exactly right. Whenever they talk about not defined, they mean bottom 0. I can't divide by 0. So basically, you're at their tangent is sine over cosine. So they're really saying, hey, where's the cosine 0? So let's go to the unit circle. Here it is. Cosine is x value. You tell me. What dot's on the unit circle? How about this dot? Does this dot have an x value 0? No, he's over something, I don't know, up something. He doesn't have an x value 0. What dots on the unit circle have an x value, a cosine of 0? This is where unit circle is great. When you know the unit circle, you can handle trig and write on through calculus. Because you can picture all these questions they're asking you. Where's the, what x values? Give me the dots that have x values that are over 0. Where are they? Right there. 90. Isn't his x value over 0 up 1? Isn't his x 0? His cosine 0? And this one? Over 0 down 1. Isn't his cosine, his x 0? At 90 and at 270. Makes sense? So many little silly questions. Range of cotan. Yeah, I'm just going to have to draw these out for you. Do you know sine? Sine starts at 0 and goes up and down, up and down. Keeps going both directions. Sine. Cosine's the same thing. He just starts high and goes like that, right? Cosine, same thing. But for both these functions, their range, for sine and cosine, I know they're asking cotan. I'll get to that. But first off, for sine and cosine. The range of sine and cosine is from a -1 to a +1. Remember, that's their range. Remember that from your previous class. Their domain, their left and right, is -infinity to +infinity. That's for sine and cosine. Now, when it comes to tangent and cotangent, they're a little different. They have these asymptotes. Well, tangent does, first off. At -π/2 to π/2, and does a bunch of snakes. And he just kind of keeps going. He just keeps snaking. So that's what tangent does. Cotan does the same thing. It's just the snakes are in a little different spot. I'm sorry, the lines are, and they go down instead of up. But it's basically the same deal. So here, let me separate these. So that's basically the deal. Tangent and cotangent, they're just a bunch of snakes, okay? So what's the domain and the range? What's the range of tangent or cotan, same thing? How far, how high, how low? -infinity to +infinity. And the domain is everything except those vertical asymptotes have to be skipped for the domain. All right, so this one is all real numbers. Cotangent range of cotan is all real numbers. Goes as low as you want, high as you want. All right, we're going to have to stop there. The other ones are hopefully not too hard. Come see me if you need help. Be glad to help you. We're out of time.